So let's continue on with the rest of today's daily packet. But actually, before I continue, one thing I do want to explain more clearly is with the absolute value. Okay. For example, so if I had, let's just call this f of x. Okay. If I had f of x equal the absolute value of x, I don't know, plus 3, and I wanted to find f of negative x. Okay, and then it might have confused some of you to when I made this absolute value of x. Didn't really explain it, so let me explain it even more. So what does the absolute value of negative x mean? Okay, when you have negative x, it's essentially saying negative 1 times x. Okay, so that's taking the absolute value of negative 1 times the absolute value of x. So then I get 1 times absolute value of x, which gives us absolute value of x. So also works for like if I even had like a negative 3 x. Okay, this is 3 absolute value of x. Okay, using the same steps as here. Okay, so some of you, that's just to clarify, because I did ask what is the absolute value of negative x. It does equal x. However, we wanted to keep the absolute values, so I just rewrote negative x a different way, which was this right here. All right. So now let's continue on with investigating increasing, decreasing, and constant behavior of a function. All right. So I also have these graphs. Maybe it'll help. So f is increasing on I. Okay, so this is the interval I. If f of x1 is less than f of x2 for all x1 less than x2 on I. Okay, so x1 and x2, they're less than each other. x1 is less than x2. But when I evaluate f of x1, that would be less than than when I evaluate f of x2. That's when f is increasing. Okay, f is decreasing on this interval if f of x1 is greater than x2, f of x2 for all x1 less than x2. So I guess another thing is it's all. Okay, so if I had like, something like this, okay, you cannot tell me, so this is not, you cannot just say that this is increasing. Okay, the reason why, because it stops increasing right here. Okay, so you have to make another little interval for that. And again, f is constant on I if f of x1 is equal to f of x2 for all x1 and x2 on I. Okay, so x1 and x2, they're equal to each other. Or not equal, sorry. For any x1, x2, the y's are equal. Okay, so this happens when, and it makes sense, right? Because f of x, when f of x equals 3, that is a constant. Okay, so no matter what x I put in, x1, x2, x7, whatever, I will always get out a 3. All right. So let's do this example over to my right. Okay, we want to use interval notation to write the intervals over which f is increasing, decreasing, and constant. Okay. Right. So we can do this one of two ways. So first there's increasing. Okay, hold on. F increasing, f decreasing, f const. Okay. So people do it multiple ways. Some people might just look for all the increasing, and then they look for all the decreasing, and then they all look for all the constants. Another way to do it is just to go from left to right, and that's actually what I'm going to do. So let's go ahead. So when we're talking about increasing, decreasing, and constants, we're always going to use parentheses. Okay. So let's start. Over here, okay, since I have a dot right here, okay, that means it's not going to infinity. Our domain starts at x equals -6. Okay, so when it's increasing, okay, so when we're talking about interval notation, about the intervals where f is increasing. We're talking about when the y's are increasing, decreasing, or constant. That tells, we know that by telling them the x. Okay, so these are all the x values we are looking at. So this one is from -6 to -2. Okay, so right here to here. Maybe. Okay, that's the interval I was looking at. Okay, this is always increasing. No matter what x1, x2 I pick in this interval, it is increasing. Okay, I'm going to look at the next interval. The next interval is right here. It's at -2 and 1. And as you can see, it's flat, it's constant. Okay, so this is right here, so it's going to be -2, 1. Okay, now let's look at the next interval, which is 1 to 3, and again, it is increasing. Because it's increasing, I'm adding another interval here, so I have to separate them with the union. This becomes 1, 3, and then let's look at the next interval. It is 1 to 5. It is also constant, so again, we got to combine them with the union. This is 3, 5. Okay, and last but not least, there's also this little dip. Again, there is a dot, so that makes it finite. Okay, so the decreasing interval would be 5 to 6. If this was an arrow, okay, if this was like this, then the interval, okay, if it had, so I'm going to put in a different color. So if it was like that, the interval would have been 5 to infinity. Same thing over here. Okay, I'll make this green. If this was not finite, if it was going down, then over here it would have been -infinity to -2. Okay, different colors just to show that's not the final answer. It's just like talking about scenarios. All right, so, and this is how, investigating if it's increasing, decreasing, or constant. So now, let's talk about the final section of this, final subsection of this section. All right, the last topic we'll be talking about before our next test. Okay, it is determining relative minima and maxima of a function. So let's start with a definition. F of A is a relative maximum of f if there exists an open interval containing A such that f of A is greater than or equal to f of x for all x in the interval. Okay. F of B is a relative minimum of f if there exists an open interval containing B such that f of B is less than or equal to f of x for all x in the interval. Okay, so relative maximum, you can also say relative maxima. Okay, relative minimum, minima. Right? Note. An open interval is an interval in which the endpoints are not included. And it is represented by an open circle. So, so if you just see an open circle, it's not included. So if I had like this graph like this, right, but I had an open circle right here, okay, this would not be, this right here, this would not be a minimum, okay, because it's not included. All right, let's continue. So if an ordered pair A, f of A corresponds to a relative minimum or relative maximum, we interpret the coordinate as follows. The x-coordinate is considered the location of the relative maximum or minimum within the domain of the function. The y-coordinate is considered the value of the relative maximum or minimum, telling us how high or low the graph is at that point. Okay, so also like with the interval notation right here, right, we use like all these y's, they're considered the value, right? We want to find the values of f when they're increasing and decreasing or constant. So we got to tell you have to tell the location, okay, which is why we use the x values. The x values is the location of where the y's are at. All right, so let's just do an example. Okay, so for the graph shown below, determine the location and value of any relative maxima. Okay, that is part 1 of our example, and we're going to use the graph on the right. Okay, so relative maxima, what is that saying? They are relative maximums. Another way is to think it's a local maximum. Okay, it's important I emphasize local because there are global maximums and minimums, but we're not going to worry about them right now. So when I look at this graph, okay, I can't, so these technically, they have arrows. Okay, since they have arrows, so yeah, these are taller than, say, like this point, like any of these points. However, we cannot consider them a maximum because there's no stopping point. Okay, we can't pinpoint a specific interval and say that it's a maximum. Okay, because you can say, oh, -10 is a maximum, but there will be another x that I can find a greater maximum. Okay, so yeah, the endpoints in this case do not count. All right, especially even in locals, they don't count anyways, if I remember correctly. So let's start. So what is location? Location is x values. Okay, and then what is the value? The value is the y. Okay, so remember maxima, it's going to be right here. There's 3 points I'm looking at. Okay, and when I look at this one, okay, this is at x is equal to -1. Oh, not -1, geez. +1. Okay. And then the value is y is equal to -1. So another way to say it is at x equals 1, the function has a relative maximum of -1. Okay, for value, I'm not really sure. I think I'll just keep it at -1. Maybe at, I think we'll just see what Alex takes. Okay, but personally, I like this saying better. Okay, this was just kind of breaking it up before I wrote my final answer. Okay, now we want to determine the location and value of any relative minima. Okay, so as you can see, we have 2 minimums right here. Okay. Sorry, I was reading something. Okay, so there's 2 right here. So what does that say? So first of all, what are these? We can even talk about the points first. We have -2, -3, and we also have 4, -6. Okay, these are our local minimums. Okay. So remember, our locations are our x, and our values are our y's. Okay, so at x is equal to -2, the function has a relative min of -3. Okay. In addition, we also have x is equal to 4, and then we're going to write the same thing, but of -6. Okay. So I guess I didn't really explain how I got these. Okay, that's what I paused for, just to think about explaining. Okay, but let's look at this relative maximum. What is the definition? So f of a is a relative maximum of f if there exists an open interval containing a such that f of a is greater than or equal to f of x. So how do we think about that? So in this case, my f of a, okay, f of a is equal to f of 1, right? So that means the y value of this, okay, f of 1, this y value, if I took this open interval, so like say right here to here, so my y values represent here, okay, no matter what x I pick on the graph, my y values are less than this point right here. It is less than f of 1, which is -1, okay? And as you can see, like these are -2, -3, -5, okay? All of these y's are less than this, okay? And then also, I'm only going to talk about one of these minimums because same concept, okay? But again, okay, we have f of b. What is f of b? F of b in this case is f of -2. Okay, you can also look at f of 4. Okay, but again, same argument. But again, if I picked an interval, okay, you can even go from here to here. Okay, as you can see, this f of b, my f of b, or f of -2, it is equal to -3, right? But if I pick any x along this interval, okay, I'm always going to get a y that is greater than -3. So even if I picked here, my y is 0. Here, my y is -2, or right here, my y is -2. We can have something like, because it says f of a less than or equal to, or greater than or equal to, so if I had something like this maybe, okay, that's fine. This would still be a local maximum, okay, because if I pick some x's, they can still be equal, okay, or the y's can still be equal. So that is it for the rest of this section. So of course, if you guys have any questions, please let me know. And good luck on your test on Friday, and I will see you all on Monday. Bye.